So there are some more information that I would like to share with you, and I also want to address new possibilities for collaboration. Last week, actually, we were all in Norway doing a combined final meeting and a fabric field test. For this field test, we had made garments in the form of ponchos, as you can see here on some of them. So we had different fabrics and different treatments that were evaluated. And we were very lucky. We actually got rain for 2 days, so we could really do some fabric testing. And you can see some photos to the right. So we both tested outside when we were hiking in quite harsh conditions, and we were also testing fabrics inside, and we were discussing a lot about the treatments and sort of the different types of fabrics. Some conclusions, and this has to some extent been addressed already, but the same DVR may provide different function on different structured fabrics. One conclusion was also that all garments get wet during heavy rain. But we also noted that there were some that formed these very nice drops for a slightly longer time, which may then prolong or the time until you have a complete water film on the garment. But once you have this water film on the garment, then it's really the membrane that is important to hinder the water to penetrate into the inner side, so that you sort of feel that you get wet or that you get wet. And an interesting observation also is that a quick drying is very important between rain showers. So if you had garments that sort of dried up in between, you got some very nice drops on the garment when it started to rain the next time. But if the garment was sort of moist or still wet, the water drops from the rain started to wet the garment directly. So no bead formation was observed then if the garment was moist or wet from the beginning. You can never communicate too much. So when we were in Finse, there were a lot of other people staying where we were staying, outdoor people, people that like to be outside in the nature and wear these outdoor garments. A very small survey, but there were still quite many that had never heard about PFAS before. And they did not know, many did not know if their garments contain PFAS or not. There were many people that never re-impregnate their outdoor garments, and also quite many that have never ever actively chosen to purchase a PFAS-free product. So here it also highlights this change in mindset and communication to the consumers. We did also see some consumer willingness. So when they got to know about this, no one said no when we asked if they would buy an outdoor garment with a PFAS-free finish, even though they have to re-impregnate it more often. And also to some extent that they are willing to pay more for outdoor garments if they know that it is for sure PFAS-free. So we do also see a willingness among the consumers. This was one question that I received earlier about PFAS testing. And we also write about this in the guide, but basically we divide it in two different types of analysis. One is compliance testing, and this is sort of common to test for specific substances. If a product contains sort of regulated substances such as PFOA or the PFOA related substances or any other substances that are on the RSL requirement list. But then there's also another type of testing that we address and highlight to investigate, and in order to find out if you have PFAS or not, we suggest total fluorine as a measurement to see if there is any intentionally added PFAS in the product. And it can be used on both liquid, solids, and powders. We have done some measurement, and this is in collaboration with Stockholm University, and these are total fluorine analysis on fabrics. So we have 5 different textiles or fabrics in this case, and we have all the blue bars are fabrics that we know do contain PFAS, and we also have C0 treated fabrics that doesn't give any measurable fluorine in the analysis. So this could be a first screening method, meaning that if you detect concentrations that suggests intentionally added PFAS and motivate further investigations in potential uses and contamination. So if you find it, you can sort of start discussing about where does it come from, etc. So we suggest this as a first analysis step. Some take-home messages from today is to increase the dialogue and collaboration in the supply chain and work together. Look for other potential uses of PFAS than in the DVR to become completely PFAS-free and avoid contamination. And we also encourage to perform risk assessment of alternatives or substitutes to avoid regrettable substitution. And here the transparency in the supply chain is very important. I also want to highlight that we are now ending POPFREE stage 3, but at the same time we are trying to form a competence center. We realize that there's still a lot to do when it comes to substitution of PFAS. We find new uses of PFAS and new perspectives of PFAS, such as the waste treatment, which is a big thing, sort of what you do with the PFAS and how what's happening, and how do you make sure that the alternatives are not becoming a problem in the waste management later on. So we are now, we do have 1-year planning project, and we will submit an application in, it should be March 2023. So if you are interested in discussing and see if this is something for you, please contact me and we'll see. We can take the discussion from there. But there is still a lot to do when it comes to PFAS and alternatives. Yes, and this was the aims with the webinar, and I really hope that you now are feel very encouraged and motivated to also download this guide and also to read it. And we hope that you have received our learnings from the project, and also that you feel even more encouraged now to communicate and collaborate in this quite challenging topic.